All right, let's just dive right into this explainer. We hear so much about modern AI, right? But we rarely actually pop the hood to see just how incredibly closely its architecture resembles something you intimately understand, your own brain. So today, we're going to demystify the mechanics of AI transformers by looking at how they selectively focus on information, quite literally mimicking the human mind.
Think about it. Right now, you are using your biological cognitive spotlight to focus on my words. You aren't consciously processing, say, the hum of your refrigerator or the exact temperature of the room. Your brain is aggressively filtering sensory input to spotlight what actually matters in this exact moment. And the wild part? Modern AI does the exact same thing, just mathematically. How does a machine know what matters in a massive sea of data? Well, it uses an attention mechanism.
So here's our roadmap. We're going to break this down into 6 clear pillars: the cognitive spotlight, the math behind the magic, multitasking in global context, the parallel processing revolution, why context is everything, and finally, a deeper AI insight.
Starting off with pillar number 1, the cognitive spotlight, or filtering the noise.
Okay, so just like your brain filters sensory information, transformers use a mechanism called self-attention. Instead of looking at a massive block of data and treating every single word equally, the system applies a mathematical weighting system. It calculates a score to figure out exactly how much one piece of data, or a token, should pay attention to another. It's dynamically highlighting the crucial pieces as it reads through the information.
When you put human selective focus and AI self-attention side by side, the mirroring is uncanny. Biology emphasizes relevant stimuli to keep you from getting totally overwhelmed, right? While the AI computes mathematical relationships to highlight important tokens in a sequence for the exact same reason. It's not magic at all. It's a structural imitation of how we naturally process reality.
Which brings us to part 2, the math behind the magic. Let's talk about queries, keys, and values. So, instead of biological neurons firing, the machine maps each piece of data to query, key, and value vectors. And vectors are really just lists of numbers that represent meaning. Think of it like this. The query is what the system is currently looking for, the key is what a specific token contains, and the value is the actual information that gets passed along if there's a match. By comparing queries and keys, the AI figures out exactly where to point its spotlight.
Okay, don't let this formula intimidate you. This is simply the mathematical equivalent of your brain asking, hey, which parts of this sentence actually matter right now? The Q and K are multiplied to see how similar they are. That result is scaled down, run through a function called softmax to turn it into a nice clean percentage, and then multiplied by the value. Literally, a math filter for relevance.
Moving right along to step 3, multitasking and global context, connecting the dots.
This is where it gets super fascinating. You know how you can listen to someone's tone of voice, process their vocabulary, and read their body language all at the exact same time? Transformers do this using multi-head attention. They assign different heads to handle completely different linguistic tasks. One head might track subject-verb agreement, while another figures out long-range references, and a third looks at semantic similarity. They're all running parallel cognitive pathways to build a complete picture. And that brings us directly to context. Older AI, like recurrent neural networks, had to read sequentially, left to right, one word at a time. But transformers, they access all tokens simultaneously. If you read a massive paragraph about France, and a page later it mentions that country, your memory connects those ideas effortlessly. Because transformers have global access to everything at once, they handle those long-range dependencies exactly like you do.
Part 4, the parallel processing revolution. Let's talk about scaling up.
Your human attention networks operate in parallel all across your brain, with different regions firing simultaneously to construct reality. Transformers functionally imitate this by processing entire sequences all at once. They aren't moving step by step. They're computing all those queries, keys, and values for every single word in a sentence at the exact same moment.
And this right here is the absolute secret sauce for why transformers were able to scale up into the massive models we use today. Parallel processing means they can fully utilize modern hardware, specifically GPUs. Which is kind of funny, because GPUs were originally designed to render video game graphics, but they just happen to be perfect for running thousands of calculations at once. This parallelism is the bedrock that allows models like GPT to train on huge chunks of the entire internet in realistic timeframes.
Okay, part 5, why context is everything. Let's look at dynamic meaning. Think about the word point. As a human, you instantly know if I mean the sharp tip of a pencil or a gesture I'm making with my finger, entirely based on the context of the sentence. Because transformers use attention to look at all surrounding tokens simultaneously, they dynamically adjust a word's meaning based on its neighbors. This is exactly why they are so insanely good at translation, summarization, and complex reasoning. They aren't just reading words, they're mapping the entire contextual web between them.
Which brings us to our final pillar, the deeper AI insight, the functional imitation.
If we lay this all out, the architectural triumph of transformers becomes crystal clear. Everything perfectly aligns. Your neural spotlighting maps directly to QKV similarity scoring. Your parallel brain networks map to multi-head attention and GPU operations. It is a stunning, direct translation of cognitive mechanics into pure math.
But, and this is a really crucial takeaway, machines are not biologically sentient. They aren't thinking or feeling the way we do. As we see here, they don't replicate biological attention. They functionally imitate its core properties. They imitate selective focus, context-dependent interpretation, and parallel processing. And that functional imitation is exactly why they completely dominate natural language processing in computer vision today.
So as multimodal AI continues to evolve, taking in video, audio, and text all at once, just like our own senses do, we're left with a massive question. How far can this mathematical imitation of the human mind actually go? I mean, if functional imitation got us this far, what happens when the scale increases by another order of magnitude? It's definitely something to keep your own cognitive spotlight focused on. Thanks for tuning into this explainer, and keep questioning the mechanics behind the magic.